So again, that's just going to look like an equation. So you could have like y equals x squared or something, and then you have another one that's in the same variables. Okay, so then like y equals x cubed, something like that. Two equations. And the next definition we have is a system of linear equations. So now you're looking at the same exact thing except they're linear. So do you guys know what linear means? Yes, so it's a line. So it's when you have an equation and your highest degree of your variables is 1. So for that, we'll put a system of equations in which each equation is linear. So again, that might look something like y equals x plus 1. Like, you know, that's just going to be a straight line on a graph. And then our last definition is a solution of a system of equations is, and this one's pretty basic, like a solution, is an assignment of values for the variables that makes each equation in the system true. So we're going to look at a few examples here, but we'll write that down for now, and then I'll explain a little bit better. So an assignment of values for the variables that makes each equation true in the system. Okay, are these terms at all familiar? Like any of the words? So you can do thumbs up or thumbs down. Are you familiar with any of these definitions? Good. Okay, so now the title of this, we're looking at systems of linear equations in two variables. So here we'll look at the number of solutions. So you're going to have a solution when it's true. So like when both equations are at the same spot. So in our first example, just looking at it, how many solutions do you guys think that there's going to be? One. Yes, we're going to have one solution because it's true where they're the same at one point. So here is one solution. All right, then example 2, how many solutions do you think is going to be there? No solutions. Because the two equations, they do not cross at any point. So they're never going to be the same. So here we're going to have no solutions. And one way to tell is that here we have the same two beginnings of equations, but the end isn't the same. So like if I were to, basically what this is saying is if 2x minus y is equal to 1 and 2x minus y is also equal to 2, then you could say 1 is equal to 2, but we know that's not true. So no solutions there. And then the third one, how many solutions do you think are on that one? You have, again, this is 2 lines. You have 2 lines there. 2 equations. So if you think about it, when they're crossing and at a point that's one solution, when they're together, how many solutions are there? Yeah, so it's infinitely many solutions because they're right on top of each other. So here we're going to have infinite. All right. So those 3 are kind of like the main things we're going to look at when we're doing substitution and elimination. So we will begin with substitution. Okay, so with substitution, there are 3 main steps we can take. Has anyone done substitution before? Are you guys familiar at all? Or is this fresh? Kind of familiar? Okay. Well, we're going through it anyway. So, for substitution, we're going to start with solving for one variable. So that's just basically solving for x or y. Doesn't matter which one. And then we're going to substitute that in. And then we're going to back substitute it to find the opposite. Okay, so those are the 3 steps we're going to take. So for our first problem, so 1, we're going to solve for one variable. I'll write that down. And also we can solve either equation. It doesn't really matter which one. So in this case, I'm going to solve in the top, I'm going to solve for x. Again, it wouldn't matter if you solve for y. So we'll solve for x here. So we have x plus y equals 2. And then what do you do to solve for x? Yes, subtract the y. So then we get x equals 2 minus y. Boom. Solve for one variable. Step 1, done. Then we're going to substitute. So we're going to substitute this in to the opposite equation. So this, we're going to substitute into here. But it's going to go in the x. So when we do that, we'll get 2 minus y minus 2y equals 0. Does that make sense how we plug that in to the other equation? And now we have the second equation in terms of y. So then we can solve for y. Now solving for y, what do you do? Simple algebra. You got it. Negative y minus 2y gets you? Yep. So 2 minus 3y equals 0. Then if we add the 3y over, we get 2 equals 3y. Divide, you get y equals 2/3. So there we found one variable, which is y. Do you guys have any idea what back substitute might mean? Like, how do you think we're going to find for x, or solve for x?
You put the y in for the top equation.
Yep, so you just plug y back in. Back substitute. So we'll do it in this equation that we already had. So we have x plus y equals 2. We know y equals 2/3, so then we'll get x plus 2/3 equals 2. And if we subtract the 2/3 over, what do you get? 2 minus 2/3.
Sorry.
4/3? Yes. So then we get x equals 4/3. So then we will write this as a coordinate. So we have 4/3 is equal to x, and then 2/3 is y. All right, are you guys good up until there? Found x and y. And after you find x and y, what you can do, if you're like really not sure if you're right or not, you can plug those back into your equations, and then if it's right, then you know that it's right because it works for both. So we're just going to do that really quick. So if we plug in 4/3 to the top equation and 2/3, we get 4/3 plus 2/3 equals 2, which we know is true because we just did that. And then, so we'll check that off. And then for the bottom one, which is the one we didn't do when we solved, we can check that. So we get 4/3 minus 2 times 2/3 equals 0. I'm running out of room a little bit. Then you get 4/3 minus 4/3 when you multiply that 2 in. And then you get 0 equals 0, which is true. So that is the way you can check your work. All right, now we're going to go down to this next problem. So we're again going to start with step 1, which is solving for one variable. Do you guys have, again, you can solve for a variable in the top or the bottom equation, it doesn't matter, and you can solve for x or y. So is there a specific variable you would like to solve for? Okay, I'll give you a hint. It's a lot easier when you don't have to divide at the end. So if there's not a coefficient on one of your variables, that's probably the one you're going to want to solve for. So we'll solve for this x right here because, like I said, like if you're solving for this 4x right here, you're going to subtract, or you're going to add your 6 over, and then you're going to have to divide by 4, and that might get you fractions. Might look a little bit messy. So it's just easier if you have a variable that has no coefficient, you don't have to divide. So we'll solve for that. We have x minus 7y equals 14. And then we'll add the 7y over. And then we'll get x equals 14 plus 7y. Then our next step is to substitute. So we can substitute x back in to this equation. So we're going to substitute x in right there. And we'll get 4 times 14 plus 7y minus 6y equals 12. Then what we'll do is we'll use distributive property to multiply in and then add coefficients. So you guys can go ahead and do that. Wait. Okay. Is everyone good with distributive property? You know how to do that? Perfect. And then after we get to this point, what can you do next? Yep, you can combine the y's. So you would do 28 minus 6 and get 22y. You solve that 56. And then what can we do with the 56? Subtract it over. We get 22y equals negative 44. And then we get y equals negative 2. So now that we solve for y, we can plug that back in and find x. So if we plug this negative 2 in there, we get x minus 7 times negative 2 equals 14. X plus 14 equals 14. Subtract 14 over. And then we get x equals 0. Is everybody good on the math there? You understand how to do the math? Perfect. Is everyone good with these steps for solving substitute, back substitute? All right. We're going to do one more together on substitution. The first two were a case scenario where up here we have one solution, right? So if you were to graph those two equations, you'd get a point where they meet. This next one is going to be a little bit different, but we will get through it. Okay. Now for this one. One again, solve for a variable. Now, in this one, none of our variables have no coefficient or 1 as their coefficient. So we're going to end up having to divide. Is there a specific one you guys want to solve for? 6y. All right, we'll solve for y here. So we're going to do negative 2x plus 6y equals negative 4. Here, I'd actually suggest solving for negative 2, because then when you divide, it'll be a whole number. Same thing up top if you wanted to. Look at the smallest coefficient, because typically at the end, like if we solve for 5x up top, we divide 10 by 5 and 15 by 5, and that would give you a whole number. Same thing here, if we solve by, or if we divide by 2 at the end, solve for x, then it's going to be a whole number. So we'll subtract the 6y over. And then here's what I'm talking about. So like when we divide right here, it's not going to be a fraction. It'll look pretty. So we'll divide by negative 2. And then we get x equals 2 plus 3y. Is everybody good that far? All right. Step 2, we're going to substitute. So we'll plug this in to, we're going to plug this in right there. So we'll get 5 times 2 plus 3y minus 15y equals 10. So now we're solving for y. So when you use distributive property and combine, what do you end up getting on your left side of the equation? Yes, Noah? Are you saying it? I can hear you saying it.
10 plus 15y.
Yes. Then when you subtract those 15s, what do you get? 10 equals 10. All right, now we're in a little bit of a weird situation now because we didn't solve for y, and that was the goal, right? But we do know, we do know that 10 is equal to 10. That is true, right? So if we look back up here, which one of those do you think it would look like? If it's a true statement. It's kind of tricky. So it's going to look something like this third one where we have infinitely many solutions. So that is going to be our answer. But the reason is because down here, our equations right here are the same thing. And so when you graph it, if you were to graph those two, they would be like this on top of each other. And since 10 equal to 10 is true, we know that the solutions are the same. But say if it said 10 is equal to 0, that's not true. So your answer would be no solutions. And we'll do a problem like that later. But we still have to find the variables for this. It's just going to look a little bit different. So if you get something that's true when you substitute, what you can do is we'll put it in terms of t. So we'll do x is equal to t. And then we can take what we found. Oh, wait, maybe I want to do, no, that's right. So then we're going to take this right here and plug in t for x. So x is equal to t, and then we'll get t is equal to 2 plus 3y. So now we can find y. So basically we're just making a new variable because it's the same thing. So like if we plug in 1, it's going to get the same thing out for both equations. So then here we'll have to solve for y. We have to get it in terms of y if we want to know what y is. So we'll subtract the 2 over, get 3y equals t minus 2. And then when we divide, we get y equals t minus 2 over 3. Or you can write it as t over 3 minus 2 over 3. It doesn't really matter which way. They're the same thing. But then we have that in terms of x and y. So we would write it exactly as we would write it if it was a whole number. So then you get t for x, and then for y you get t over 3 minus 2 over 3. And that's your answer. So because it has infinitely many solutions and not just one, that's why we have the variable t in there, because there's a lot of different things that you could plug in and get out. Like you're going to get a solution for, if you put 1 in for x, if you put 2 in for x, you're going to get the same solution. So that is why it's not just one like definite answer like 0, 5. All right, the next one I'm going to have you work on by yourself for a second, and then we can come together and go over it. If you guys have any questions or you're stuck on any parts, make sure you use this, your steps, and it'll help you. Oh, yes. Wait, is that the last one we did? Or the first one we did? Is that good? All right, are we about done? Did anybody get stuck and you're like, I don't know what I'm doing? Okay, well. Okay, we'll start this one. Sorry, I gotta scroll back down. And if you haven't finished, that's okay. Just pick up. Okay, what variable did you guys solve for? Which equation? The bottom one? What'd you solve for? Perfect. Okay, we're solving for y in the bottom equation. So we'll get 6x plus 3y equals 0. And then you'll subtract your 6x, right? 3y equals negative, wait a second, 6x. And then y equals negative 2x. Is that what you guys got? Perfect. And you might have done a different one. Again, it doesn't matter. It's going to get you the same answer. And then we will substitute in. So we'll do 4x plus 2 times negative 2x equals negative 5. So this time we're now trying to solve for x. When you multiply, you get 4x minus 4x equals negative 5. And then if you subtract those, you just get 0. So you get 0 equals negative 5. All right, what do we know about 0 equals negative 5? Is that true or false? False, right, that's not true. So when we get this as our answer, what do we know about the solutions of the equations? No solutions, yep. So we're going to have no solutions in this one. So your answer will just be no solution. Okay, so for substitution, we went through kind of 3 different areas that you can get for your answers. So you're either going to get a solution, you're going to get infinitely many solutions where you got to set x or y equal to t and then solve for the other one, or you're going to get no solution. So what is your guys' confidence level on substitution? Give me a 1 through 5 on your hands. Like 1, I'm really lost. 5, I think I got this. Okay, good. Well, if you guys need any extra help or just want to come hang out with me, got office hours. Alrighty, next we're going to go to elimination. And this is another way that we can solve. So actually, I'll leave this up here. Alright, elimination. We got 3 steps again that we can use. The first one is adjust the coefficients. Two is eliminate a variable. And then 3 is the same thing, back substitute. All right. So for this one, we're starting with number 1, adjust the coefficients. So in elimination, or in substitution, the way we started was we solved for a variable so we could substitute it, hence the name substitution. And then elimination, we're going to try and get 2 of our variables to be the same. So that way we can add the 2 equations together and one of them will be eliminated. Hence the name elimination. So here we're trying to eliminate something as opposed to solving and then substituting. So what we'll do for the first one is we're going to adjust the coefficients so that way 2 of our variables are the same. So you either want to get your x's to be the same or your y's to be the same. And the way you can do that is by multiplying something by the entire equation. So in this first one, we're going to multiply the entire top by 2. Does anybody know why I did that? Okay, the reason I multiplied by 2 is because after I multiply this entire equation by 2, I get that, and then my other equation, I'm just keeping the same. Now what do you notice? Again, we're trying to get, adjusting our coefficient so we can get the same, one of our variables to be the same thing so they can become eliminated. We're trying to eliminate a variable. So here, now I have negative 2y and positive 2y. So I got those variables to be the same, but opposites, because if I add these 2 equations together, then I get 19x, negative 2y plus 2y, 0. So our y's are canceled out. And then negative 76. So that's the main thing in elimination. We eliminated those, we made the variables the same so that way we could eliminate them. We made their coefficients the same so we could eliminate them. And now we can just solve for x easily. So negative 76 divided by 19 is -4, yes. All right, and then we finished step 1 and 2 then. And then we just have step 3, which is back substitute. So you can substitute in either, really. It doesn't matter because you're going to get the same answer for both. So I'm just going to do the top one. 5 times -4 minus y equals -21. Then you get -20 minus y equals -21. Negative y equals -1, and then y equals 1. So for your solution, what do you get? -4, 1. Perfect. And again, just like the problems up top that we did with substitution, if you're really worried that I don't know if that's the right answer, you can plug those two numbers back into both equations, and if it's a true statement, then you know that you got it right. All right, we will go down to this next problem, and I'm going to have you guys do this one on your own. So again, start by adjusting your coefficients. I'll get you started, actually, and then I'll let you go and try it on your own. So if we adjust the coefficients, in this one, you're going to have to multiply the top and bottom by something because you have 2 and 3, and you can't really, unless you're multiplying by a fraction, which, again, that just gets messy. So what do you think we're going to multiply the top by? 3. And then we'll multiply the bottom by 2. So then you get -6x minus 6y equals 12 for your top equation. And then for the bottom, we get 6x plus 6y equals -12. Okay, and then I'm going to let you guys continue, and we'll see what you get. Remember, you still have to get a solution even if it's infinitely many solutions. You still have to find something that you can put down. So remember, you have to set x equal to t or something. You have to have a solution. Kind of like we did with the substitution problem. Can you help? Did you get infinitely many solutions? Yeah. Yeah, that's right. So then all you have to do is plug in t for x somewhere and then solve for y. So you just plug it into the top. So you get -2t minus 2y equals 4 and then solve for y. And that. Okay. Equals 4. Yeah, so just erase this. You don't need that at the beginning. Yeah, and then equals 4 and then solve for y. And then you'll get it in terms of t.
I don't really know that. What we do after.
Yeah, so since it's a true statement, you have infinitely many solutions, right? So then you can just set x equal to t. And then, kind of like we did with the substitution problem. So if you set x equal to t, then you're just getting your answer in terms of t. So then you can plug in t for x, and then you solve for y, and then your y will be equal to t, some equation with t. And then your answer would be t, comma, whatever you get for y. Does that make sense? Okay, you're on the right track. No, you're on the right track. So once you get x equal to t, which is good, set equal to t, then you can just plug in t for x anywhere. So you can plug in t for the top equation, and then you solve for y. So your answer is gonna have t in it somewhere. Yes. Thank you. Yep. Yep. I think it is. I mean, I don't know if it's exactly. I can check. But it looks right. I mean, you have t and then plug t in. Yeah. Looks right to me. All right, we'll go ahead and do this one as a class. So I think all of you pretty much got to the point where if you add these together, you're getting 0 is equal to 0 on both sides. And when 0 is equal to 0, that's true. So we know that there's infinitely many solutions. Infinite. So when we get infinitely many solutions, again, you're still going to have something that you can put down for your answer. It's not just going to be no solution because there's infinitely many. So we'll start by setting x equal to t, and we'll just get everything in terms of t. So once you set x equal to t, it's just pretty easy from there because all you have to do is plug in t for x. So you can plug it into either, but we'll plug it into the top. So we get negative 2t minus 2y equals 4. And then if we add this 2y over, or we're actually adding the 2t over, my bad. Add 2t. Then we get negative 2y equals 4 plus 2t. Divide by negative 2. And we get negative 2 minus t. So then our answer would be t, because that's what we got for x. We just set it equal to t. And then for y, we have negative 2 minus t. Does anybody have any questions about that one? I think the infinitely many solutions one is probably the trickiest because you have to kind of make up your own equations there in your answer. And then, okay, we will continue to the next one. We'll do this one together really quick. So again, you got to think a little bit when you're multiplying to adjust your coefficients because you're trying to get them to be the same thing. So what is something that we can multiply by the top and the bottom? Yes. What?
5 and 2. 5 on the top.
Yep, 5 and 2. Perfect. So 5 and 2 gets us 40 for x and 40 for 20 once we multiply. You could do like 8 on the bottom and 20 on the top because you know that they would cancel, but your numbers are just going to be really large. So the easier way is to do 5 and 2. And then once we do that, we get 40x minus 30y equals 90, I believe. Correct me if I'm wrong. And then on the bottom, we get negative 40x plus 30y equals negative 88. So now, when we eliminate, we are trying to eliminate our x's, but unfortunately, our y's are also eliminated here. So we get 0 on that side is equal to 2. And what do we know about that? Yep, it's not true. So our answer is going to be no solution. Okay, that was our last problem for elimination. So how confident are you guys on elimination? 1 through 5 on your fingers. Perfect. Awesome. Okay, we will go down and we'll start some application problems. We might not get through all of them, but that's okay. So in these problems, unless it specifically says substitution or elimination, it doesn't matter which one you do. You're going to get the same answer. So if you prefer one over the other, you can do that. I'm sure on the test, Dr. Joe will have specific ones that you have to do. So definitely know how to do both. But if it doesn't specify, you can use whichever one you like better. All right, first application problem, we have a boat travels 20 miles upstream in 150 minutes. The same trip downstream takes 60 minutes. What is the speed of the boat relative to the stream, and what is the speed of the current? So here we have to make our own equation. So I suggest starting by looking at what you're looking for. So we're looking for here the speed of the boat and the speed of the current. So if that's what we're looking for, and we've been solving for x and y, what can we say x and y are going to be equal to? X is probably going to be equal to speed of the boat, and y is going to be equal to, speed of the current. So we'll write that down just so we don't forget. So x is equal to speed of the boat, y is equal to speed of the current. So yeah, when you get application problems for elimination and substitution, I highly suggesting, you want to look at the problem because the other numbers are in there that are going to help you, but start with the very last question to figure out what you're looking for. All right, now we will set up our equations. So we're looking at if our speed of the boat and speed of the current are going to be in the same thing, we're going to have x and y in each line, right? So we are given that we're going 20 miles upstream, and this says the same trip downstream. So we're going to assume we're going 20 miles this way, and then 20 miles back. And then we also know, use pink, that it's taken 150 minutes upstream, and then 60 minutes downstream. So when we're making these equations, I'm just going to write this off to the side so we can remember. But my top equation is going to be when I'm going upstream, and my bottom equation is going to be when I'm going downstream. Okay, so then we can look at what is happening when we're going upstream. The only thing with this problem is you're going to need the speed formula, and I'm just going to write it off to the side. So speed equals, does anybody know the speed formula? You have distance and time. Speed is just distance divided by time. Because if you're thinking of it like in your car, how fast you're driving, it's miles per hour. So we have miles per hour, miles divided by hour, distance divided by time. Okay, so then when we are going upstream, and if the current's going this way, we're fighting against the current, right? So we're going to have to take our speed of the boat and subtract the speed of the current to get our speed because you're fighting against it. So we'll just get x minus y is equal to, and it's going to be the speed. So we have distance, I don't know why I put times, but distance divided by time. And for upstream, we know it's 20 miles. So we know our distance is 20 miles up top. And the time is 150 minutes, but we know 150 minutes is 2.5 hours. So we're just going to convert that if we want to do miles per hour. So then we're going to do 20 divided by 2.5. So that's going to be our equation for upstream. And then downstream, if you're traveling downstream and the current's going with you, what do you imagine you're going to do to those variables in the equation? Did you say add? Oh, they said add. Somebody said add. We're going to add them because they're going together. Okay? So we have x plus y equals, and then same thing over here, except we're going for 1 hour downstream. But it's the same miles, so then we're going to get 20 over 1. So we can rewrite these equations to make them look a little bit better. So we don't have fractions. So 20 divided by 2.5 is 8. And then 20 divided by 1 is obviously 20. So that is what we get for our equations. The hardest part in the application problems is setting up the equations. But if you just look at what it's asking you and then what they're giving you, it's pretty easy. So really quickly, we're going to solve this. We're going to find x and y so we can figure out our speed of the boat and speed of the current. So do you guys want to do substitution or elimination? Up to you. Substitution. Okay, what do we want to solve for? Top what? Top x. Okay. So if we're solving for x in the top equation, we get x equals 8 plus y. And then we're going to plug that in here, right, in the bottom equation. So then we get 8 plus y equals 20. And then 8 plus 2y equals 20. I'm running out of room. Then we get 2y equals, subtract the 8, you get 12. And then y equals 6. So then we know that 6 is the speed of the current, miles per hour, 6 miles per hour. And then if we plug that back in, we'll just plug it into the top equation. Sorry, I'm running out of room, so I'm at weird places. But we get x minus 6 equals 8, and x equals 14. So speed of the boat is 6 miles per hour. Or no, speed of the boat is 14. Sorry, I got them mixed up. Speed of the boat is 14 miles per hour. And then your speed of the current is going to be 6 miles per hour. All right. Again, if you guys have any questions, come to me. Also, you can email me if you want, and I'll be happy to answer over email, or I'd be happy to set up an appointment with you, and we can find a time to meet. Whatever works. So just let me know. Thank you, guys. Of course. Hopefully you learned something good about substitution and elimination today. I don't think so. I think you need to shut it.
Okay, let's have to teach it again. Let's do it again.
I'll just teach it to Dr. Sue. Thank you. Thanks. Did you learn a lot? Yes. Good. Hopefully substitution and elimination goes really well in the test.
How so? Just you're sitting in here.
Yes. Alexis is teaching today too.
Yeah, I knew that.
Yeah. Well, I texted her and told her because we had to do our practice
Yeah.
things, and she was like, "Wait, I'm teaching that day too." I was like, "Oh, that's funny."
I think that's what it is. My heart.
Oh.
Oh yeah, I've heard about.